Here is our drawing regarding stair. We have a plan over here, we have sections over here, and it is very important to have stair cross section in order to find out the steel. Now we have flight number 1 over here with landing, and we have flight number 2 over here. So this is basically section at A, and this is section at BB. Section at A in this direction, and section at BB for the flight number 2 at this direction. Now for UAEs, I have just a draw here and the stair reinforcement plan as well. It is for UAEs. Now at flight 1 and the landing, we are using the bent up bar. You can see these red bars are basically the bent up bar that are starting right from the stairs beam up till landing 1. So these are. Then we need to add here the distribution bars in the flight number 1, not in the landing. But in landing again we will use the bent up bar in this direction. Okay, so we will have the both of the bars, the main and the distribution bars over here. And at the end yellow bars are the distribution bar. Let me simply go here in the cross section, the longitudinal section. And here at section at A, you can see this is basically the bent up bar. Starting right from the stair beam, it is going toward this direction up to this position at landing 1. Then again the bent up bar from the landing 1 to the next flight. So this is basically the bar you can see over here, and these dotted bars are basically the distribution bars in the direction of width. So here in AutoCAD it is very easy to find out BBS, or it could be any quantity for the stairs. Definitely manual calculations are a bit hard, and we need to use their Pythagoras theorem and different kind of things in order to find out the length. And as I said earlier, if you have tool, and nowadays most of the companies prefer Primavera and Plant Swift in order to do the takeoff, so why not we use these softwares? Well, definitely we need to take the benefit over here instead of going here the manual calculations for 1 hour and the 2 hours. Here we can do all of this stuff very quickly, so we will use here the AutoCAD. Now here first of all we have stair beam, and in stair beam is a very simple one. We have find out the grade beam and the top beam, and as compared to that, this is very simple one. We have 4 bars over here in the direction of our width, and the dia is mentioned over here T10. You can find out this one as well. And we have stirrup over here with T at the dia 300 centimeters, the spacing in the direction of width. We will find right from the bars over here the bent up bars for the stair. Then we will find out the distribution bars at flight number 1. Then we will go for the flight number 2, the bent up bars in the distribution bars here in flight number 2 as well. So let me move here in this Excel, and we will start right from this position. Serial number as 1. Members, we have a stair, and there is no need to add here the length for the stair, or you can give here the horizontal length, and no problem. Put here the breadth of our stair, that is 1200 millimeter. You can check in the plan as well. Breadth, because we are right now finding the bent up bar, and it will be in the direction of our width. In order to find out numbers, we need to find out this one, 1200. So this is what we need to find out in this direction. Now there is no need to put here the height as well. A particular placing of bar, so it is a bent up bar. Next to it, we need to go here for the spacing, and let's check the spacing over here for the bent up bar. It is mentioned over here for bent up bar we are using T10 150 center to center. So 150. Let's create the bar shape over here. Let's take the bar shape over here. First of all, it is going to start right from the beams, and we have development length over here in this direction. Then we have inclined shape, and then the straight. So let's create the one over here. I'll simply go here, click on this drop down, draw border option, and I'll start right from this position. Okay, and then we will move toward this direction, and then like this. So this is how this bar look like. Now next to it, we need to go for the bend directions, and it is very important to check the bends over here in this stair. So how we can check the bends? First of all, we will check the bend at this position. So we will go here in annotate. Then in the dimension panel, you can see we have one of the option regarding the dimensions. We have different dimension, the linear, the align, the angular. So we will go with the angular option, and we will find out the angle over here. First line, then the second line. Now angle over here is 143 degree. We need to take the external. So it is 143 degree. So based on that, we need to find out the bend direction. Remember one thing, what was the base angle in BBS basic? I have already explained all of this. So in bend direction, what is the base angle? 45 degree is the base angle. So we will simply go here 143 divided by 45 in order to find out the value. So bend direction value for 143 degree angle is 3.17. Remember this one, 3.17. So instead of 135, I'll put here the angles as 143. 143. And what is the value over here? Equal to, we have two bends over here. Let me check this one as well, the top one. If this one is 143, definitely this one also be 143. So let's check it. Look here, 143. So we have two bends over here equal to 2 into 3.17, the value into diagonal. So this is why I said that BBS basic is very important. There I have explained all of this stuff. Now we have a 90 degree as well, equal to 2 into diagonal. Done from here. So here we have 190 degree, 140. Now we need to add here the bend or the development length. So we have, yes, definitely bend or development length over here. Let's check this one. It is LD is 270 millimeter. Mean development length is 270. I'll put it over here, 270. Next to it, basically we need to go for the overlap if we have any. So I'll put it here as well, equal to 270, because this is also development length. No need for overlap. And what about the dia of this? But dia we are using over here is 10 mm. Sorry, 10 mm. Concrete cover is 25 mm in the stair. Let me check it as well over here. Yes, it is I think mentioned over here 25. And next to it, what we need to do is we need to find out the number of bars. So number of bar, these are bent bar in the direction of our width. So span divided by spacing is over here +1. Hit enter. So we need total of 9 bars and multiply by number of members 1, and then total numbers will be equal to number of bars multiplied by number of members. So it is simple one. Now in order to find out total length, first of all we need to find out the cut length, and we have find out already the development length. Next to it we need to find out this length. It is mentioned over here in the AutoCAD, and this is basically the benefit of AutoCAD. 115.52. Let me put it over here. I'll put it over here. 115.52, and then we need to find out this inclined length. So this inclined length is very difficult through manual calculations, I know, but use AutoCAD, no problem. And this is I have find out it over here, right from this position up till this position. It is total of it is total mention over here 4024.35. 4024.35. Next to it we need to find out the final, the landing length. So let me simply go here, and it is total of 839.96. 839.96. Put it over here, equal to 839.96. Done. So I'll move it toward this direction. Let me align this one. I'll right click over here and format cell, go into the alignment and choose this kind of alignment over here, like this. So we can even go for the again and the alignment, and we can go like this as well, no problem. Press OK from here, and you can see. And now next to it, what we need to do is we need to find out the total length, and total length will be equal to what? Cut length, this one plus this one plus this one plus this one. And then next to it we need to do the bend direction for 90 degree, 143 degree, and multiply it with total numbers. So total numbers are over here, divided by 1000 in order to convert it into meter. Hit enter. So we have find out the bent up bars over here. Now next to it we need to find out the bent up bar in the next flight as well. So again I'll go here, I'll copy all of this stuff from here, paste it over here. Sorry, copy this one, paste it over here. And as this is again the bent up bar, let me check it in the section as well, in the next section. It is bent a bar T10 150 centimeter. It is okay. Now here we need to find out right from this position up till here, and the length is mentioned over here. No problem for us. Yes, and we need to check the angle, and angle will also be same. Let me check the bend directions over here as well. Yes, 143 degree. So it is okay for us. Let me simply go here and to create the shape over here. First of all, we have the straight shape, and then we have this kind of shape. So next we have only 143 degree, and what was the value? 3.17. So equal to 3.17 multiplied by dia bar is over here. Next to it we do not have any kind of bend or bevelment and no overlap. Dia we are using 10 mm, 25 is a concrete cover, and number of bars. So number of bars will be same because span is same, placing span is same, so it is okay. Span divided by spacing plus 1 in the flight number 2 as well, multiplied by number of members as 1, and then total numbers will be equal to number of bars multiplied by number of members. Hit enter. Next we need to find out the total length, and first of all we need to find out here the cut length. Cut length here is first of all we have 12 16.67 the horizontal, 12, and then we need to find out the inclined. What about the inclined? It is 1308.33. Now you can do the alignment. We have done it already, no problem. And next to it we need to find out the total length, and total length will be equal to this one plus this one, minus we need to do the bend direction, multiply it with total numbers, divide it on 1000 in order to convert it into meter. So we have find out what the bent up bars in the stair in flight number 1 plus landing, flight number 2 plus landing as well. Now in next tutorial, let me show you over here as well. It is important. So we can find out these red bars over here, reinforcement plan over here, and these yellow bars is basically the distribution bars. You can see over here. And in this regard, what we need to do is we need to find out it for the flight number 1 and flight number 2. So let's move over here. And what about the flight number 1? It is going to start right from this position up till here. So we need to find out this inclined length in order to find out number of bars. And in order to find out cut length, what we need to do is from the width of the stair, we need to deduct the concrete cover from both ends. So let's move over here. This is number 2, this is number 3. And next to it, what we need to do is we need to go here, the stair. What about the length? So first of all, we will find out on the landing 1, sorry, the flight 1, right from this position up here, we need the total length. And this inclined length is basically the total length, right from this position up till here we need, where we need to place these distribution bars. So it is total of 4024.35, 40. Okay, breadth is 1200, there is no need to add the height, so this is distribution bars, flight 1. Next to it we need to go for the center distance. So it is 200 center T8 we are using, sorry, 200. Next to it we need to create a shape for this, so click over here, and this is straightforward shape. Next there is no any bend direction over here, no bend development length, no overlap. So dia bar is 8 mm and concrete cover is 25 mm. Number of bars, so in order to find out number of bars, it will be equal to the total length, the inclined length, span divided by spacing is over here plus 1 will give us number of bars. So it is total of 21.12, means we need to round down this one. So click over here, round down, start the bracket, comma, close the bracket. Next to it, what we need to do is we need to find out number of members as 1, flight 1, and then total numbers will be equal to number of bars multiplied by number of members. Hit enter. Next we need to find out the total length, and total length will be equal to cut length multiplied by total numbers. And in order to find out cut length, from the total width of our stair we need to deduct concrete cover from both ends. Hope you understand this one, because these are basic things now. And next we will go for the total length, and total length will be equal to cut length multiplied by total numbers, because we do not have any kind of bend deductions over here. And cut length multiplied by total numbers divided by 1000 in order to convert it into meter. So here we have the total as 24.15 for the flight number 1. Again, copy all of this stuff from here and simply paste it over here. It is basically number 4, and next to it, in this length we need to change it because this is flight number 2 length. This is the length 1308.33. 1308.33. The rest is same. This is flight number 200 center, and let's create the shape for this. Before that, let me unmerge this one to create a shape. Again, this is straight shape, no bend development length over here, but dia bar is 8 mm and 25. And what about the number of bars? So copy this formula and paste it over here. Copy this, paste it over here. So span divided by spacing, look here, span divided by spacing plus 1, multiply by number of members as 1, and then total numbers will be equal to number of bars multiplied by number of members. So next to it, what we need to do is we need to find out the cut length, and cut length will be equal to width of our stair minus concrete cover from both ends. Hit enter. Let me move it toward this direction. Next to it, we need to find out the total length, and in order to find out total length, we will simply copy this formula, paste it over here. Double click over here, this one multiply by total numbers divided by 1000. So we can find out all of the bars here in the stairs